So now we're going to get to the core of object-oriented programming, and that's really understanding objects and classes. Right now they may seem similar, but they're related, but they're really not the same. Um, what we've got is beyond the primitive types, we can create a complex type or a user-defined type that we want. This would basically be called an object. An instance of it would be an object. The actual definition is actually what's known as a class. Each object basically has two components. It has a state, which refers to the individual variables of the object, and a behavior, which refers to the method that the object can execute, or methods that can be executed upon the state of the object. So let's say we have a type called rectangle. So rectangle would be our class because it is the definition. Each one of these boxes represents an object. Now, I don't want you to look at the boxes as being rectangles. I would just use those as items in PowerPoint here. This object is different than this object, which is different than this object, because they are all different lengths and widths, as you can see, but they are all different locations in memory. So I have three individual objects in three areas of memory that all will run the same types of methods or have access to the same methods, but actually have a different state because their lengths and widths are actually different. But even if their lengths and widths were the same, it would be the same as having two cars in a parking lot that were identical cars. They would generally have the similar state, but they are two unique and independent objects. In order to create objects, we need to create a new class, which provides the definition for the state and behavior. So we will basically create this class, rectangle. Now, this is not a public class. The public class is the one that will contain the main function. Any other class doesn't need the public keyword in front of it. What we do is we will put these variable declarations no longer inside of the method, we will put them inside of the class. So they are outside of the methods but within the class. And these variables are known as object variables. These variables will be available for any object that is of the type rectangle, in this case a width and a height. And similarly, as we've done in the other public class, we can declare our methods. So what you'll notice is when someone calls the method setWidth with a value, say 6, that 6 goes into W. And then the actual method will actually put that 6, which is in W, and put it into width, which is here. And so each individual object has its own width and height. Even though the class rectangle has one definition for width and height, every object that I created, those individual boxes, will have their own width and height. And the same holds true for setHeight. SetHeight, I'll pass in a value into h, and that value will then go into height, which will go into the height variable of the particular object. So the rectangle from the previous class we'll use for now. When we use this class, we basically use the dot notation to reference the object, method, or variable. So rectangle, where the definition is what we call the class. When we actually use it is when we call it an object, when we create an instance of it. And creating the instance of it is easy because we've allocated memory, and we do so with this keyword new. We have rectangle R, which you read the same way as you do any other variable. R is a variable of type rectangle. And just like the arrays, we will assign it the memory allocation, in this case of a rectangle. Notice though that because it's an object, we will have the open parenthesis, close parenthesis right away. This is called a constructor, which we will work with a little bit later. So what it does is it looks at the rectangle class and says, I need to create memory. Well, how much memory is it going to create? It's going to allocate enough space for all of the object variables. So if there were two variables of type integer, it will create enough space for two integers. If I had 6 variables, 2 integers, 2 strings, and 2 doubles, it would create enough memory where it would have 2 integers, 2 strings, and 2 doubles. And then R would point to that location just as we did with arrays. But now if we want to reference the width and the height variable of a particular object, in this case R, where R is pointing to, we would use the dot notation and say R dot width, the width variable of the R object equals 5, and the height variable of the R object equals 6. We could have easily declared another line here that said rectangle R2 equals new rectangle, in which case below it we would use R2.width equals say 10, R2.height equals 4. And so you'd be able to see that each object is completely different because it has different states. When we call methods, we do the same thing. The methods within the object are called using the dot notation. So we will say, use the setWidth method of rectangle and pass in a 5. But you're working with the R object. So the R object is going, which has its own height and width. That particular object's width will be set to 5, and that particular object's height will be set to 6. Again, if you look at the code previous on 2 slides, you'll see how the setWidth and setHeight methods actually work. So we can have multiple objects, as I mentioned, where we have rectangle R equals new rectangle, rectangle R2 equals new rectangle. These are two independent objects. And we have R.setWidth 5 and R.setWidth 6. So the R object is pointing over here to this allocation of memory. It sets the width to 5 and the height to 6. And the R2 points to another allocation of memory, and it sets the width to 7 and sets the height to 10. So in your sample code, you have a geometry class, and it shows you how a class is written within a file. There's an example video as well that will show that. So a few notes. The class represents the definition, the state and behavior of the variables and methods. The class defines what is the actual code, the specific variables, as well as the methods that are allocated. When we create an object, we do this by allocating the memory with the new keyword and a constructor. And we can create as many instances of a class or these objects from a class, but each class itself is unique. Each object is unique. So a rectangle as a class is different than a square. And each rectangle that we create, R, R1, R2, R3, are unique objects.